This bittersweet heat is suffocating.
Okay then, so this is mechanics now, question number 6. We have at time t seconds where t is greater than or equal to 0, a particle P moves in the xy plane in such a way that its velocity v meters per second is given by v is equal to t to the minus a half I. Is it a plus or a minus? No, it's a minus 4tj. Okay, when t equals 1, p is at the point A. When r is equal to 4, p is at point B. Find the exact distance A then. Okay, so we need to get this in terms of distance away. So we need to integrate our way back up to displacement. So we need to integrate this. So we need to, I'll call it r for now. Doesn't really matter what we call it. So we get 2t to the half. So we're adding 1 dividing by the new power, plus some constant c1, okay, which will be called I in the I direction, and I'm going to plus, while integrating that, will get you minus 2 over t squared, okay, plus constant c2j, okay, so OA. So using position vectors, I get 2 plus c1, okay, I, and I need to add minus 2 plus c2, j, so I get to that point. For OB, I'm going to use OB minus OA, that's the way I'm going to do this. So I need to sub in the 4 now. And the other side, I shall get minus 32. Yeah, minus 32 plus C2J. So AB, find AB. Well, that's OB, take away OA from your vectors knowledge, which is 2I, take away 30J. Well, to find the length of AB, we give it as a third, so I end up with a square root of 2 squared plus 30 squared. Do it on the calculator. I get the square root of 2 squared plus 30 squared. And I'm getting 2 root 226. Right then, a couple of mark schemes. So, let's find where these 6 marks are allocated, shall we? Right then, line 1, integrating with variable t, and including constants where are required. Finding the lengths OA and OB, so substituting we'll get your mark. I'll get 2 marks and 3 marks for stating that AB is OB minus OA, get 3 marks there. Actually doing that will get the 4th mark. The 5th mark will be the 2 squared plus 30 squared, and the final mark for the simplified third of 2 square root 226. And that will get you all the 6 marks for question number 6. Okay, question number 7. So we've got tan alpha giving us 3/4. We've got some box on a rough road with a coefficient of friction as 0.14. We've got an angle, and that angle should be alpha. We want to find the acceleration of the crate. Okay, well, this is a very funny one because we need to know what sine and cosine of alpha is. So if we find that sine alpha, well, using the right angle triangle, you can find that as 3/5. So I'll tell you that cosine of alpha would be the 4/5. Yeah, using sine theta and cos theta and replacing the GD. That's the way I work those out. Now, we can also put some annotations on the diagram. This box is weight down at 20G, and we also have some friction pulling it back, and we have the normal reaction force, don't we? And this is angle alpha. This will be then 40 sine of alpha at the side, and this will be 40 cosine of alpha. Okay, part A, well, the F from the formula that you need to learn is that. So substituting in, I get F is the 0.14 R. Now we need to find what R is when we're resolving upwards. Now R when we're resolving upwards is the R plus the 40, okay, multiplied by that 3/5, okay, and I want to take away that 20G, and that should be equal to 0, which implies that R is the 172. Okay, you can try that in your calculator if you really want to. Move everything else to the other side. So 40 times 3/5, 24, plus 20 times 9.8, and I'm getting the 172 as required. Now part B. So I want to resolve horizontally now. To resolve. Right then. So from that, we can find our friction coming all the way with R, and we know that the F is equal to mu times the normal reaction force. So the 0.14, and I'll multiply by the R, which I've now found is 172. Let's try that on the calculator. And I'm going to get a 24.08 as the force in that direction, which is good, but we now need to find the value of A. We're using F equals ma probably, is the way I want to go about this. So now I want to resolve horizontally through the plane. To do that, I want to do 40 times 4/5, of course, and I need to take away this value of F, which is the 24.08. Okay, and that should be equal to the 20A. Okay, well, solving that, well, we need to do 40 times 4/5, which is 32. Take away the 24.808, which will get me that, and I need to divide that by 20. And I'm getting A is equal to 0.396 ms to the minus 2. Okay. And that is the value of acceleration. Part B, I'm just going to explain that to you, just because it's a little bit easier to explain than write out in full. But as there is a greater downward force, the normal reaction will be large, so the friction is larger, so the Kratz acceleration will be therefore less. Okay, easy 2 marks that one. So let's have a look at the answers here then. So 6 marks for part A, finding the acceleration. Well, we are given a mark for resolving the diagram, which is good. The second mark is for identifying the forces and getting resolving upwards, another mark. Getting a third mark for substituting and get the 24.0.8. Now we're getting a fourth mark for resolving horizontally and getting to 20A. Getting the fifth mark for the F equals 0.14R and getting the values of sine and cosine of alpha. And the sixth mark is solving that final equation horizontally to get the A is the 0.396. Okay? And that's how we can get the full marks for question number 7. Okay then, question number 8. In this question, I and J are horizontal unit vectors due east and the north respectively. Okay, and position vectors are given relative to the fixed point. So, a particle P moves with constant acceleration, and that's a big giveaway because if it was variable, I'd have to use differentiation and integration. So So I don't need to use that here, so I can use my Subat equations. Funnily enough, I've written Subat down on the board. So, let's have a look then. I've also got the questions below, so if I'm looking down, I'm looking directly onto the papers. Okay. So, how can we deal with this then? Well, if we can use s equals ut plus 1/2 at squared, we'll probably use that somewhere. Underline my vectors, of course. So, let's find the value of s. Now, s is the 7i minus 10j in the question. Now, we don't have a u. In fact, no, we do have a u. Sorry, we do have a u. That's the 2i minus 3j. Yeah. It's the v we don't have. We don't have the v. We need to find the acceleration, and we know the time is 2. So using this one that doesn't include the v, I can substitute in and solve. So I've got the 7i minus 10j. Now, I want that equal to the 4i take away the 6j. Yeah. And I want to add on this 2a as well. Because don't forget, I need to square that a. T squared. Okay. Alright. Well, let's get everything in terms of a. So that 2a is the 3i take away the 4j. So doing that will get you a mark. Now solving that will get you down to a, so dividing through by 2, which is 3/2 I take away 2j. Now that's not the end of the problem, because I need to find what the value of a now is. The value of a will be the square root of 3/2 squared take away or plus 2 squared square rooted. Let's do that on the calculator, of course, because I'm class whiz, if you've not seen my videos before. So I'm going to get 5 halves. Okay, 25 over 4, so 5 halves. Okay. Rooted 5 halves, or 2.5 ms to the minus 2. Okay, that's part A. On to part B then. So we'll want to be writing Subat down again. Which one will I use this time? Well, let's have a look at the question again. So find the time it takes for P to travel from A to B. V equals U plus AT. We don't know the time again. That's what we want to find. The A is the 4i plus the 8.8j. We're given that. The U is the 2i minus 3j. Yeah. Plus 2 lots of the acceleration of the 3/2 I take away the 2j, which is 5i take away 7j. V equals U plus AT could be an issue. In fact, no, we could use V equals U plus AT, and you know what, we'll go with that, shall we? Yeah, we will. We'll go V equals U plus AT. We'll use that one. So doing that, then I'm going to get V is the 5i take away the 7j plus the A, which is the 4i plus 8.8j times T, which is 5 plus 4ti. Okay. Take away 7 plus the 8.8 tj. Okay, so the 5 plus 4t will be the minus 7 plus 8.8t. So 12 is 4.8t. So t is 12 over 4.8. 12 over 4.8. 5 halves again. I'll try 5. 3.5 and it's not in meters, it's seconds, sorry. Okay, and that is question 8. So mark scheme wise, 4 marks apiece for these questions. So determining, you need to use S equals UC plus half AT squared will get you a mark. Finding all subarc parts, substituting in will get you 3rd mark. 4th mark is to find the length, and getting down to the 2.5 ms to the minus 2 will get you a mark. That's ED 4 marks. Part B, getting to that will get you a mark. Stating all those will get 5i minus 7j will get you a mark. That's 2 marks. Getting down to here, 12 equals 4.8t, and getting down to t is 2.5 seconds. Will get you all 4 marks. So that's all 8 marks in total, and that is all the marks for question number 8. Okay, question number 9. So we have this diagram that I've drawn out for you already. I'm immediately going to draw another right angle triangle because I feel like I'm going to be needing it in a minute. So I'm going to get that drawn and put an angle alpha in it, just to make sure. I've obviously got this length t going on, but also I'm going to need to resolve the forces, which means this is going to be 3/5 t and not 4/5 t. I'm going to need those. That's the only bit I'm going to write down. The rest I'm going to do actually now. So, immediately I want to take moments without doubt. So I'm going to take moments about A. So taking moments about A then, I'm going to be getting minus A times mg. I'm going to take away x multiplied by 3mg plus 2a multiplied by 3/5 t, which is 0. So I get 6/5 AT. This looks so weird, I tell you. Which is AMG plus 3mxg. Solving off for t then, I'm going to get that 5/6 AMG plus 3mxg all over A. It's not quite what they want in the question, 5mg of 3x plus a. So that's 5mg of a plus 3x all over a. Is that any better? Yeah. No, that's very okay. Part B. So, hold up a minute, that's not what we want, do we? The 6 should be on the bottom, just over menacing this. I have seen that error. I do apologise. We'll get right back into the video. So keep watching, don't forget to like and subscribe. Let's carry on with question number 9 and number 10 coming up to the end of the paper. See you then. Oh, we want to find x in terms of A. Well, this is quite a short question, isn't it? So that 2mg is going to be that 4/5 t that we've just found. Now that 4/5 t will be the adjacent over the hypotenuse, don't forget. Okay, so using this bottom part of the diagram. So, I know the value for t now, I've just worked that out, which is the 4/5 times that 3mg of 3x plus a all over a. That should be over 6a actually, shouldn't it? Apologies, that should be over 6a. How did I not spot that? Massive apologies there. Hopefully you didn't get that wrong just because of me. Of me being an idiot. What else could you do here? You could multiply by the 5, I guess. Multiply by the 7 halves. And deal with that way. To get the 15a mg. So multiply by the 6a as well at the same time. I guess that could work. Is that 5mg of 3x plus a. So So the 3a is the a plus 3x. Implies that 3x is equal to 2a. So x is the 2/3 a. Okay. Part C. I have to flip over because part C is on the other side depending on how I print it. So, part C. So I want to find the value of tan beta then. Well, this is not any better, is it? So if I do f, take away mg, take away the 3mg plus 3/5 t. So I get f is equal to 4mg minus 3/5 of that 5mg of a plus 3x times that 3/5 a all over 6a, which is that 4mg take away 1/2 mg by 3, which is 5/2. Is that right? Yeah, 5/2. So tan of beta would be 5/2 mg divided by the 2mg, obviously all that adjacent of course, which is 10/8, 5/4. Obviously the mg's will cancel. Yeah. Same as multiplying this by 1/2, the 5/2 by 1/2. Yeah. Part D then. So for part D, explain how this will illustrate the possible positions of P. So the T has to be less than 5 mg. Yeah. So the A plus the 3x over the 6a has to be less than or equal to 1. So the A plus 3x is going to be less than 6a. So the 3x is going to be less than or equal to 5a. So that means that x is less than or equal to 5/3 a. Or 5a over 3, you could row as well. So if the x exceeds 5a over 3, it's going to break, isn't it? Yeah? So the rope will break if it exceeds this amount. Right then. I don't have time to go through the mark scheme, but if you would like to see how I've done it, funnily enough, that's how I did it. That was quite complex, I must say. That is quite hard. So question 10 coming up, the hardest one in the mechanics paper, I believe. So let's have a look. Question 10 on the way. Alright then, here we are, question number 10. So question 10 is about a projectile as seen in the diagram, and we ideally, if we have a look at this 0.75 value that we're given, which is here. Okay, now the first question I would put into values of x and y, and then put my Subat down. Because as you can't tell already, I have wrote the Subat equations down, and I've wrote down all 5. This 5th one isn't really used that much, but I have put it down anyway. If you rearrange that, you will get the v equals u plus at. I just like writing it in a, but that's completely up to you. So we've got Subat in 3 dimensions, and not 2. Okay. So the s we don't have. We don't have this distance. But we do know that the distance in the y is 1. Okay. Now looking at the diagram, we know that this is 3 meters above the ground. And this value over here, okay, is 20. Yep. It's 20 meters, should I say. This is 0 meters. This is the start of firing this projectile at angle alpha and value u. Now the question says to find the value of u. Now initially I want to go straight in with number 1. So we've got v squared minus u squared. In fact no, let's write it in the way I've got v squared equals u squared plus 2as. I know that is a u, that's how I'm doing my v's, okay. So looking at the question on here, on this piece of paper I've got in front of me, I could sub in the 0 for that. I now need to work out what the u is. The u is, this one is u sine of alpha, breaking that apart, and that will be u cosine of alpha. Okay, and the acceleration for the y direction will be negative g. In the x direction we don't have, so that'll be 0. And we do not have the time either. So v squared minus u squared equals 2as would be the sensible way to do this. So 0 squared is equal to u squared sine squared alpha plus 2 times minus g times 1. Okay, so getting the u squared on it, u squared sine squared alpha on its own, u squared sine squared alpha then is 2g, which implies that u squared is equal to 2g over sine squared alpha. Okay, and that is how we can leave that. You could square root, but I'm not going to. You could if you really wanted to find the value of u, but that's how I would leave it, because it'll be helpful for part B. So part B, again I need me to do that in the u, in both directions, in the x and the y. So in the x, I've got the distance of 20, I've got again u cosine alpha and u sine alpha for the u's. The s is the negative 10.25, is it? Yeah, something like that. Come to what the diagram says. So the acceleration again will be negative g. Over here it will be 0. We need to find out what this time is. Okay, well, so in the x, we've got s is equal to ut plus 1/2 at squared. And then we've got 20 is equal to ut cosine of alpha, which implies getting t on its own is equal to 20 over u cosine of alpha. Okay. In the y direction, I've got minus 1.25 is equal to u sine of alpha and 20 over u cosine alpha. Okay, I need to take away 1/2 g 20 over u cosine alpha. Okay, now up here now for the question for part B, I've got the minus 1.25 is equal to 20 tan alpha, so multiplying up and getting everything over will get you into tan alpha. Minus 20g over u squared cos squared alpha. Okay. It'll be 200, won't it? Not 20, it'll be 200. Now what else can we deal with here? Oh, I could start manipulating that. Is equal to 20 tan alpha. Minus the 200g over cos squared alpha multiplied by sine squared alpha over 2g. could do it like that way. And I'm left with a quadratic in 10, minus 1.25, take away 20, 10 alpha. Plus 100 10 squared alpha. And that will be equal to 0. Okay, so now I need the values for tan alpha. Okay, so tan alpha will give you two values. We've got a quadratic in 10, need to get my calculator. Okay, calculator found. Casio class Wiz, if you've not seen my videos before. So we need to go and stay in menu number 1. We need to do inverse tan of, in fact no, I could actually go straight to my quadratic solver. So that is A for quadrinomial functions. We need to go to number 2, polynomial degree 2. So I have negative 100. Okay. Plus 20. And the 1.25. Okay. Oh, and my calculator is not in radians. Okay, so I've got a quarter, and I've got the negative 1 over 20. Thank you, calculator. And it does tell you the minimum and maximum. We don't need those. Okay. So, what do we need to do now? Well, it can't be negative 1 over 20. Okay, because the angle alpha is not giving us acute in the question, so we can't assume this. So that can't be true, because the angle's not acute. So I have to deal with this. Now, straight back to menu number 1, and we do inverse tan of a quarter, or arc tan of a quarter, if you like me and like writing that, which is equal to 14.0 degrees to, how many degrees? 3/6 fig? Yeah. Okay. Or 1 decimal place, if you are like that. Okay. That was big for part B. I did not expect it to be that long, but there you go. Part C. They can criticise it by saying that air resistance isn't included. Or we could talk about the spin of the ball isn't taken into account. Talk about that if you wanted to. For part D, in fact I won't do part D there, I shall do part D up here. So for part D, T is the 20 over cosine of alpha multiplied by the square root of that inverse. So it will be sine squared alpha over 2g. So straight into the calculator. So where do I want to go about this? Now cosine of alpha, I don't think we're given. No. Okay.
Hi guys, so please note while I'm editing this, to find cosine alpha and sine squared alpha, you'd have to use your triangle. So given that tan alpha is a quarter, well it's opposite over adjacent, draw a right angled triangle and you can find the sine and cosine of alpha. G is given as 9.18 at the beginning of the paper of the section for mechanics. Alright, so if you'll be able to plug that in, you should get the answer that I get. So carry on watching, like and subscribe.
Wait a second. Right, I've eventually just worked this out. You'll see it in the edit. I've gone straight to this when I've edited it out. And I eventually ended up with 1.135 when it's rounded. Okay, so 1.135. How many decimal places? I'm going to calculate it. It's 3. So 3FF. Okay, and that is that. Whew. Okay, that was hard. I don't expect anyone to get full marks on the mechanics side because it is hard, but if you do physics, it might be a little bit easier for you. So if you would like me to do any other papers apart from this one I've done, maybe the 2019 or 2020, make sure you leave it a like and subscribe, and leave me a comment of any other papers you want me to do as well, and I shall crack on with those and get those uploaded once the papers are released on the exam board website. Okay, so thank you so much for joining me, and I shall see you in the next one. Math Boy is now out of here. Bye guys.